This is Algebra 1. We're going to talk about 0-12 today. We're going to talk about different things with data and numbers and what we can do with it and what we're going to see. So, the first thing when we talk about data is, well, data is one of our options there. Our variables are not, well, these are definitions, is a variable. When we're talking about groups of things, what is a variable of a group? Or a variable itself. It's a symbol that represents a number. I like that. When we're talking about equations and stuff, actually, when we're talking about collecting data, is what we're going to basically be reviewing now, the variable, guys, is not necessarily always going to be a number. The variable might be what we're going to call a characteristic of a group. So the variable, just like you kind of think of your science classes, the variable is a characteristic of the group that we assume is different, or has different values, that assumes different values. Assumes different values. Okay, so it's a characteristic of a group that changes. Data, what's data? Data is the actual values. It's the values of the variable. So data would be the things that are changing. What are those values that are coming in? Basically, sometimes the numbers. Doesn't always have to be numbers. We could be collecting data on the colors that people like, right? Then we can actually take that and quantitatively collect it, measurements. So if I ask, hey guys, if I gave you 3 colors to choose from, I can collect data and say, which one's your favorite color of these 3? People might go and say, I like red, I like blue, I like white. And we're going to have a mix of those, right? I can quantitatively gather up that data and get a measurement. So quantitatively is when you take their units and you add them up. So adding data, or gathering, adding or gathering of the data. The categorical side of it is not the data itself, but it's of the groups. So we can kind of take a look at the organized into different categories. So organize into categories itself. So we'll say different categories. Categories of red, blue, white. So we can find out how many people like the white. But if you back up just a little bit and saying, hey, we're going to categorize it into people liking the white ones, the blue ones, or the red ones, that would be categorical data. Now we're just saying, hey, we just only have this type of data, and then you can go dive into it and say how many people like that data. And univariate data is data in one variable. So we're not using several different types of information or variable. Everything's based off one type of variable. So when we get data, now we start talking about measures of center tendency. And those things happen to be these 3 things underneath it of mean, median, mode. You guys hopefully have seen these before. You know how to use them. But what's the mean? Average, I heard. Yes. Average. And how do we find average? How do we find the mean or the average? Charlie? Yeah, add them all up. So add up the data. Then divide by how many data values used, right? So if there were 10 numbers added together, you would divide by 10. If there were 500 numbers added together, you would divide by 500. What's the median? Middle number. It's the middle number. When? What? It's kind of important. It's more than just the middle number, because your data is not going to be necessarily appropriate to do the find the median. It's the middle number when in order. It's the middle number when in order. Now, what happens if your group has an even number of data? Abby? You take the average of the middle two. So, put parentheses, when even number of data, take average of middle two, right? Take the average of the middle two when there's an even amount of data. Even number of data, or even amount of inputs. Mode. Real. Yeah, occurs the most. Number occurs the most. Now, could a group of data have more than one mode? Yes. Now, if I do 3, 3, 4, 4, 4, 5, 5, the mode of that is 4. If I threw in another 5, the mode is 4 and 5. If I put in another 3, the mode is nothing. There is no mode. You see the small difference in that? Is that if everyone has the same, then there's no mode. But if it is only certain groups, then you name those certain groups. Okay? So let's do an example here. And it says the table shows the number of hits Marcus made for his team. I want you to find the mean, median, mode. So it shows the team they played. They played the Badgers, the Hornets, the Bulldogs, Vikings, Rangers, and Panthers. And the number of hits, 3, 6, 5, 2, 3, and 7. Those are the number of hits he made during that particular game. I want you to find the mean, median, mode. I'm going to give you guys a couple seconds to try this on your own, and we'll come back together. Now, how do I find the mean, people? If I took and added all of our numbers up, what do we end up getting?
26.
So, obviously, we add them all up, and then we say, hey, I'm going to take 26 and divide by how many numbers? And so, that would be my average. First of all, guys, I want to leave it as an improper fraction if it has to be. So what would that be? Divide the top and bottom by? What's the top and bottom divisible by?
3.
It's not 3, it is a 2. So it would be 13 over 3. That's the first thing I want to do. Then, let's take it to a decimal. What's 13 divided by 3? 4.3. Repeat. Is everybody okay with that? Now, the next two things, guys. The next two things, median and mode, it only makes sense to take the numbers and put them in order. So that's what I'm going to do. Now, watch how I do this, guys. I look for the smallest number. The smallest number is a 2. Then I go through and I cross off the box. The next one is a 3 and another 3. So there are 2 3s, a 5, and then a 6, and a 7. This helps me establish, because I can look really close and say, hey, what's the mode? What's the mode? Which one happens most? A 3. So now we got mode, we got a mean, now we only have to find the median. The median, guys, it's a little bit harder to show this on the screen, but what I really would do, guys, is literally take an index finger on each hand, cover up the 7 and the 2, and start walking one space at a time in. So I'd be here for my first time, and then take a step in. My next step would be between the 3 and the 6. Another step in is 3 and 5. So now we establish that the middle happens to be between 3 and 5. Hopefully all of us would know what the exact middle between 3 and 5 is, and it's 4. But say we didn't. Say these are numbers that are not nice, they're not close. So what we do is we take 3 plus 5 and divide it by 2, which is 8 over 2, which equals 4. So your median is 4.
Can't you just do the crop?
The next thing we need to talk about when we're talking about data is the range. What is the range, guys? Someone other than the usual crowd here. That's usual. Parker, you have an answer today. How far the numbers span. I like that. How far the numbers span. Now, there's a way to actually find that. How do I find the range? Stacy, right? Sydney.
It's the highest number minus the lowest number.
Highest minus lowest. That is the range right there. Take the highest number, or I want to say last number in when it's in order, minus the first number when it's in order. You will have the range. Okay, so example number 2 says, the times in minutes it took Olivia to walk to school each day this week was 18, 15, 15, 12, and 14. Find the range. Notice it didn't ask you for the mean, median, mode, but it could, right? So at this point, we could find all 4 of them. So what should I do with these numbers? Since it's only asking for the range,
You should put them in order from least to greatest.
you could put them in order from least to greatest. That might help us because, guys, more than likely, I'm not going to just ask you for the range. I'm going to ask you for all 4 pieces, right? So I would definitely put it in order. So 12 is taken care of. Then it goes to 14. And then there's 2 15s and an 18. I've covered them all. I underlined them all. I know I did this fine. And then I can say, hey, wait a minute. 18 is my largest number. 12 is my lowest number. So 18 minus 12 is 6. So the range is 6. I could also, right now, ask you what's the mode.
15.
It's 15. There's 2 of them, and that's the only one that has the most. So the others, you just obviously follow the same rules from the last slide. The next one, guys, is talking about lower quartile, upper quartile, maximum, minimum, and interquartile range. Now, I'm going to start off with maximum, because that's pretty easy. What is the maximum? It's the biggest number. The minimum is the smallest number. So if I could go back to the list before, it'd be pretty easy to find the max and minimum values. right? When they're in order. Now, what does it mean to be lower quartile? The lower quartile, guys, is the median of the lower half. It's the median of the lower half. You know what the median is? The middle, right? Okay. But to get to the half, you need to find the median first. You kind of seeing that I'm taking half, and then what's half of half? A quarter. We're looking at the quartile. What do you think the upper quartile is? Median of the upper half. Guys, have you guys ever made a box and whisker plot?
I hate it.
Because we're going to be doing those tomorrow. Oh, that's, guys, you needed the lower and upper quartiles. All it is 5 values. You plot the 5 values, you're good to go. So we're going to make it really easy. Now, wait a minute. We know what range is. The range is the highest minus the lowest. What's the interquartile range? Yeah, it's the upper quartile, right? Upper quartile minus the lower quartile. If you take the upper quartile minus the lower quartile, you will have the 50% of the middle data. Because think about it, each quarter represents 25%. If I go from the lower quartile to the upper quartile, I'm covering 50% of your data. So looking at the problem below. The problem below says that the number of boxes Josh sold for a fundraiser each day for the last 11 days was 11, 16, 35, 26, 14, 17, 28, 29, 21, 17, and 20. Find the minimum, lower quartile, median, upper quartile, and maximum. 5 things. If you can find these 5 things, you can make a box and whisker plot tomorrow. Easy peasy. Okay? Now, obviously, this is all hinging on the numbers being in order. So, that is the first thing you shall do. What is the lowest number?
14.
So, it's a 14. 14's gone. Next.
16.
A 16, gone. Next. 17, twice. Next. 20. Next. Oh, there's a 21. Oh, I almost skipped that one. 21. 26. Uh-oh. Uh-oh. Where's 22? Oh, 22 is the first one. Ah. Now 26. 28. 29. And 35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have all 11. Now all we have to do, guys, is state the 5 things. I'm going to be nice to you guys, as in stating or saying that I can go like this. This one is the minimum. I can go over here and say this one is the... I don't have to sit there and say the maximum is 35 if I can put little arrows and point it out. Now, we need to find the lower, median, and upper quartile. But to find the lower and upper quartiles, you need to first find the median, or the middle. And so, working your way in, we find that, I'm going to change colors so that I can show this. And I start to work my way in. I would be doing this with both two hands if I was not on the screen. So the 21 is the median. Everybody get that? I moved in one spot each side. Now, to find the median of the lower and upper half, or the upper quartiles, guys, you will start with the next number that's in the group. 21, guys, is not in the lower or upper. 21 is in the middle. So I start at 20, and I start at 14. So I'm going to change colors again so that we can see us moving in there. I'm going to change to a different one. We'll use black. 14 and 20, 16 and 17. So that means 17 itself is the lower quartile, right? And do the same thing on the other side, 22 and 35. 26, 29, that means 28 is the upper quartile. You now have all 5 numbers. You're happy. If I asked you on that last problem for that interquartile range, it's subtracting that upper number minus the low number. Let's go back here. It's 28 minus 17. It's 11. The interquartile range is 11, right? 28 minus 17, which is 11. There's my interquartile range, because remember, we already talked about interquartile range. Guys, an outlier are values that are beyond the upper and lower quartiles by over 1.5 times that range. So, you take the range, which is 11, yes? What's 1.5 times 11? Take your calculators out. We've got to make this kind of quick here, guys. What is 1.5 times 11? 16.5. So anything that's above or below your upper and lower quartiles by further than 16.5 data points is considered an outlier. I'm going to go back real quick. The lower quartile was 17. If I take 16.5 away from 17, I'm way over here, right? Is there anything past that point of a half? No, there's no outliers. Going the other direction, the upper quartile was 28. What's 28 plus 16.5? 44.5? That's all within good. There are no outliers on this problem. Kind of seeing what we're doing there. I'm not going to do example 4. You could see that there are going to be, if you found it, we just talked about how to find those outliers. Again, it lies outside of 1.5 times your interquartile range. Your homework is page 39, 1 through 16, every 3. Have a fantastic day.